This is the lecture video for section 5.6, video 5. Here we're going to talking about one example using the half-angle identities to verify identities. So here are the half-angle identities we're going to use, and here is the example 5. So we want to verify the equation tangent square of x over 2 equal to secant x plus cosine x minus 2 or over secant of x minus cosine of x. We want to see if this equation is an identity. So I'm going to start from the left-hand side. So I'm using the purple one as my kind of thought sketch paper. So since I have tangent square of x minus 2, that looks like I do not have a tangent square formulas, but this is what actually talking about is tangent of x over 2 square. So whatever your tangent half angle formulas, you just square the entire formula. So when we're talking about the tangent half angle formula, we have 3 options to choose from. Both are pretty much similar difficulties to get to the answers. You can use either one of them. There is one is more neater, more shorter in terms of steps, but pretty much everything else, I mean all 3 formulas, you can get to what you want eventually. So I'm going to, for this case, I'm going to use the formula C, because this is the most neater versions for the steps. If you use the formula A, you will get exactly the same process. The only difference is you're going to have about 2 to 3 steps more, like at the beginning, more, so you can changing the original formula to the C formula versions. Similar thing for the equation B or identity B. You will need to twist it a little bit. So I'm just going to do the C version because that's the more neater one. Okay, so I'm going to using the blue pen to write my left hand side. Well, it goes to tangent of x over 2 quantity square. I'm using the C one, which is 1 minus cosine of A over sine of A. Okay. And squaring the entire expression, I got 1 minus cosine of A's quantity square divided by sine square of A. Comparing to the right hand side of the equation, the original equation, there's no sine. I have secant, which is 1 over cosine, and cosine. There's no sine for the right hand side, so I do not need the sine. So I'm going to rewrite the sine square of A as 1 minus cosine square of A from the Pythagorean identity. I'm also going to multiply the 1 minus cosine of A into 1 minus 2 times cosine of A plus cosine square of A. Okay, so you can see by looking at the structures of the steps I have versus the right hand side, I have pretty much very similar structure. I have 2 terms on the denominator, I have 3 terms on the numerator, 1 is a plus, 1 is a minus, and I also have a 2. Everything is in terms of cosine. The only difference is there's secant, which is 1 over cosine on the right hand side. I need to go to. So to have the secant, which is 1 over cosine, I decided to divide by cosine. It should be x. I write everything in terms of A. Okay, so x sine x square, cosine x square, x. Okay, so I'm going to divide everything by cosine of x. But that means I'm dividing every single term by cosine of x. Same thing for the denominator. One over cosine of x, that is secant of x. Cosine of x and cosine of x will cancel out, so we got 2. And then 1 copy of cosine of x from cosine squared x divided by cosine x. On the denominator, we also have a secant x from 1 minus cosine of x. And then 1 copy of cosine x from cosine squared x divided by cosine x. So I pretty much have the same thing except the order is slightly different. So I say this is going to equal to my right hand side. And that's it for my verify identity example 5. Okay, so just in case you feel like I do not know which equation to choose, can I just randomly pick one? Yes, you can randomly pick one. So for example, I'm using a green one. For example, I'm just going to use the equation A because that's the first one. Then I will end up with tangent of x over 2 equals to positive or negative square root of 1 minus cosine of x over 1 plus cosine of x, quantity square. Square, that means taking care of the square root, so I end up with 1 minus cosine of x over 1 plus cosine of x. Okay, so I do not have any of the 2's, any of the cosines. So what I have to do, I have to make it more complicated by multiply by its conjugate, which is 1 minus cosine of x. So I multiply both the numerator and the denominator by cosine of x. On the numerator, I got 1 minus cosine x squared. On the denominator, I got 1 minus cosine squared x, which is matching to my blue version using equation C, line number 2. And then I can just continue copying the same steps. So it's pretty similar process. It will take a little bit longer. It will be a little bit challenge because you have to make it more complicated to continue. But in general speaking, it's doable. So in order for you to know which formula to use, there's no like a one quick rule everyone to follow. You have to try to solving them for at the beginning, like a first or second steps, and see how it goes. Can you figure out how to continue, or you do not really know how to continue, and then you're going to switch in a different formula, and then try a different way. So it is going to be requires a lot of practice to be able to see, okay, which one might be a great option to start from.